Thank you, Leandro, for the nice presentation. So, as already mentioned, I would like to present you a tool for accessing the eddy covariance flux towers datasets worldwide that we are building in this period. So just a little bit of context, I guess that we all know what we are seeing in this picture. So there is a forest vegetation that is taking up CO2 from the atmosphere with the photosynthesis and releasing a little bit of CO2 with respiration. And you can see from behind the eddy covariance instrumentations that is used to measure this exchange of CO2 and also other gases. And what we measure with eddy covariance is actually the net ecosystem exchange. So for each half hour, the net between the CO2 that is taken up and the one that is released by respiration, and then we can use models to partition it between GPP, so photosynthesis, and ecosystem respiration. And eddy covariance can do that for every half hour continuously and without interfering with the ecosystem too much, or I would say at all. Okay, still for giving you a context again, this is a half-hourly time series of net ecosystem exchange. On the top, you have a cropland in France, and in the bottom, you have a forest, a pine forest in Italy. And already just taking a look to the plot, you can see the red line is the zero. And by convention, what is above the red line, so what is positive, is an emission, a net emission. And what is below zero, negative, is an uptake of carbon. Each dot is an half hour. And so you can see the trends. You can see 3 years in the top plot and 5 years in the bottom one. These are real data from the ICOS infrastructure. And you can see the trend. You can see this huge peak in summertime, and then in wintertime you have respiration that is predominant. And you can see different behavior in the forest where the peak are less pronounced but more sparse through the year. And you can so I don't want to spend too much time on this, but you can already see several features already from the time series, from the half-hourly time series. You can see this sharp decrease in the net ecosystem exchange at the mid of summertime, and this is due to harvesting, so to the harvest of the cropland. And you cannot see it, of course, in the forest. And you can also see that the forest has a less pronounced seasonality because it is a pine forest, so an evergreen forest in a Mediterranean climate, so with the winter which is not so cold, so warm enough to ensure that photosynthesis is still happening. And if you accumulate this, you can have also a direct comparison on how much carbon has been taken up by the two ecosystems, and you can see also the seasonality. This is just the sum of the net ecosystem exchange that was shown in the plot below, in the plot above, for the period where both were measuring. And you can see these data are in tons of carbon per hectare. And if you check the number at the end, you have the total amount of carbon that is taken up by these two ecosystems, where you can see that the forest is taking up, at least from this plot, more carbon than the cropland in these 3 years. However, you cannot compare really directly this data without including the uncertainty. Then, if you include uncertainty with the straight lines, you can see that basically there is no significant differences between the two, because the uncertainty is also important and tells something about the story. So this is just to give you some context of what we are talking about. What is FluxNet? FluxNet is a network of networks. So it gathers eddy covariance monitoring networks worldwide. And there are bigger and smaller networks part of it. And in this map, you can see all the stations that were part of the latest release of the dataset of the FluxNet datasets, which date back 10 years ago. So FluxNet 2015. And you can also see the main research infrastructure that were a part of it. from basically all over the world. And this constituted an enormous effort to have this release, because the processing was centralized in one place, and the data had to be standardized, and of course also the products were following standards that is crucial. But this effort was important because you cannot use this data if they come from different protocols, from different standards. They are not intercomparable. And so having all of them managed by a central entity was important to provide data that were used in so many ways for their importance and for their standardization. Now, currently, we are building a new era of FluxNet, and because we understood that this is not anymore sustainable to have a release done like that, because the number of sessions is growing, the number of years of data is also growing, and so we decided to have an agreement between all of us, all of the networks involved, to make something a little bit different in the same direction. And basically, so to let you understand better, let's imagine a user like this guy here, and they need some Flux data. So they look a bit in the internet. They find a lot of different data sets from different institutions that are maybe not part of any network, and then they find networks, but with different standards among them. Then they found FluxNet 2015 release that is everything standardized, and it is covering the globe, so it's good. But it's now it's quite old, 10 years old, so maybe they need more recent data. Then they find Ameriflux, ICOS, and those Flux that are the three bigger networks, research infrastructure or monitoring networks worldwide in the US, in Europe, and in Australia. They have more updated FluxNet-like data sets because they understood the importance of updating our actually data sets, but this was not a homogeneous effort. And then our user needs something more. He need to look for different, maybe 7 or 10 different portals where he has to create 7 to 10 different credential accounts. Maybe there are some data that they need that are not for free, so they have to pay for that. And then there are different policies that they have to respect. They have so it's a huge effort from the user perspective to get a complete data set worldwide. So our ambition now is to go beyond this situation and to help the user to find all the data sets they need in the same place, where the place is not a unique repository for all the data sets of the world, but is a tool, an informatic tool, basically, that allow the user to have a unified global search. So to find the data sets belonging to different networks in the same place. And this is coming. And the expected date is December this year. So we are working hard on this now. So I put a Vespa in the previous slide to show like a deliver guy that delivers the data at the different users. And now we call this product the shuttle, like the bus shuttle that take people to the airport, for example. So I replaced this. And so the three the three data centers and institutions that are doing this are the ones showing this map: Ameriflux in the US, ICOS, where I work in Italy, and Osflux or TERN in the Australia. And we decided to split the world, let's say, because this gave also the opportunity to increase the network. So to call for the action to join FluxNet with more data, and in particular in the underrepresented regions. And so we decided to split the areas of the world under different competencies. So the US part is carrying the Americas, basically, the Australian network, the Oceania, and we are dealing with the rest of the world. So that's why we are a little bit busy now to collect and check all the data. But it is crucial because with ICOS, we are a little bit advanced. We have more expertise on this. And so we thought that it was possible also to care Asia and Africa data sets, and also to call for more stations to join this. So let me open a little window on ICOS, on what we do, especially in particular with the reference of the data handling. We have a portal, a carbon portal, which is not managed by CMCC, is managed by Lund University in Sweden. And it is our portal is the place where the data are uploaded from the station's PIs, and where also the user can find them. The carbon portal is where all the data sets gets a PID, so a persistent identifier, a unique, let's say like a DOI to recognize the data sets and make it citable and traceable forever. This is where the user search and fetch the data object and can also preview them with their metadata. So I'm not going into details. This is the data flow, and the data flow where the carbon portal is involved. This is just to show you that it's a little bit, I would say, sophisticated, because it's not just that the user put the data somewhere and the user, that the station PIs put their data in and the user get them. Of course, metadata are part of the story. And the first thing that the PI has to upload is the metadata. Without the metadata, the data are not accepted. So the PIs send the metadata, they get the URL as a confirmation that the metadata are okay, so they can upload their data to the repository, which is a third service, let's say, a third party. The data gets the PID, and this happens both for the users and for the PIs. So the PIs upload their raw data, and then the user take the data from the same system. And this is also where we, as thematic center, so the ones caring of the processing of the raw data, are taking the raw data and uploading the product that we produce. So the ICOS Carbon Portal have a visual interface, of a graphical interface, of course, but also a SQL endpoint where you can make a search for using different parameters, of course, like the station name, but also the date or the data type. This is just an example. And if you are curious, you can click on the link and try yourself. And then from this search, you get a link for the data download and the PID and other information, of course. And if you, yes, this is a zoom on the link, and this is the persistent identifier. And I can skip this one. And if you take the link and put on the browser, you will get on the landing page where you can click on download, and then you have to accept the license, which is CC BY, of course. And so, and this is how the user get the data, but this is also doable programmatically, let's say. So this is one way to access, and this is the more user-friendly, let's say. But you can do it, of course, with a program with a CURL protocol, where basically you get a cookie as a mean of identification and of authentication. And by using this cookie, you can download the data, or you can also create an account. But the cookie for the account only lasts 28 hours, more or less. But this is just to mention that if you're curious, you can go to the GitHub page of the Carbon Portal where all the details are explained. This is just to mention what actually looks like to download the data from ICOS, and what actually the Fluxness shuttle will be doing. So this will be done by the shuttle for the for the ICOS dataset. So now this is the first plot that was when the FluxNet shuttle was conceived, and it's already 5 years old. So this one, 5 years old. You can see the FluxNet shuttle that is following this line, and you can see the different cluster that are producing the data, the eddy covariance data sets, and they keep their own portals where you can see the colors and the fonts are different, because this means that they are using different standards, but then they all put data in the FluxNet basket, and they have to be in the FluxNet standard. So the FluxNet shuttle visits all the baskets and get the data that the user queried for. And of course, the system is different for the different data centers. I already show you the Sparkle query that has to be done and this URL command to get the data. OsFlux is a little bit different way. So the metadata are in a CSV file currently, and the shuttle check the file and then get the links for the download, but they will move to an API-based system as well. They're working on it. And in the AmeriFlux, you have an API system for queries the metadata and the link to download the data. So what is the impact of this? So in the first release, we have everything centralized in one place. Now the processing is decentralized in 3 data sets: ICOS, AmeriFlux, and OsFlux. So this is streamline the procedure and increase the efficiency and the optimization of the times. This, as I was mentioning, allowed us to call for action, and we are expecting to pass from 200 sites worldwide of 10 years ago to about 1,000 sites. Then we are checking the data, so we are understanding if there are data that will need more work to be accepted, but this is our expectations. So the user will find and access the data from all this network with a single tool. So they will not even realize that they are in different portals, because the FluxNet will visit the portals in their place. And the data sets will be updated, we can say continuously, because as soon as a network have a new version of the data sets or a new site, this will be immediately made available to the shuttle. So there is no more need of a release, actually. It's a continuously updated release. And the standardization of Flux and the metadata are for the interoperability and reusability. So probably some already understood where I want to go now. Yes, I don't know if you can see. So for the fairness of the data, we are working in the direction of improving. Of course, this can also be increased more. With more metadata, for example, but we are going in the right direction, I think. So the last slides is just to show what can be the impact of this. So eddy covariance stations are expensive system, are expensive both because it's a very precise instrumentation, and precise instrumentation costs a lot, and then you have to maintain, to keep operative. And can you imagine you have a tall towers over forest with hundreds of sensors installed, and you have to keep them working, of course. You have to check that everything is working properly and to change what is not working anymore. So I took this from the ICOS handbook that we produce every year, and you can see, I don't know if it's big enough, depending on the type of station and on the type of ecosystem, the range of cost is between 135 and 865 €, for building the tower, to which you have to add between 3 and 12,000 euros per year for keep this operative. So this is a huge effort that research infrastructure and institutions worldwide are doing to build and to provide data sets, often for free and open, as we are pushing to do. And so it is worth this effort. Maybe one can ask this, and having something that increase the accessibility of the data sets and also increase the spatial representativeness is something crucial. And this is just the statistics from Web of Science, just using the key Fluxnet 2015. And you can see the impact in the number of publications and of citations. And the impact is still high despite the 10 years old data set. So can you imagine having continuously updated data sets, what can mean for people needing this data? How it is related to Open Earth Monitor? We are Fluxnet data are part of the in situ data sets that are that we are leading in CMCC. So we are leading the work package 4, which is for the in situ data sets, and one of the in situ data sets is Fluxnet data, among many other, which support a use case of the Max Planck Institute, where the footprint of the eddy covariance data are compared with the footprint of the satellite images, and the relationship between the SIF and the GPP are let's say investigated. So that's all from my side. I don't know how is the time, because I don't have any clock with me, but 2 minutes more. Okay, just to mention that if you want, I have a little demo of the shuttle. It's a Jupyter notebook just to show how it works. It's a very basic thing. It's not anything so sophisticated, but if you are curious, you can reach me out, or if you have questions, I'm here, of course.
Okay, thank you, Simone. So yeah, we still have time for 1 or 2 questions. Yeah, I have one. So you mentioned about the period of update the data. So because now with this Fluxnet shuttle, basically, as far as I understood, you have a solution that actually harvests all the different networks. So it gives the data in kind of quasi near real time or something like that. So, but what is the period of update to really get the new data? I know that depends of each network.
Yeah, exactly.
So
at the moment, it depends on each network. I don't know if at some point we will also agree on something. For IGOS, this is twice per year. So we have 2 releases every year of new data sets or new years of the existing data sets. So for the other ones, I think it's more or less 1 per year or something like that.
Okay.
I don't know I didn't see which one end was first. So.
Hi, I remember ICOS was a part of this research infrastructures at ENVRI, Environmental Research Infrastructures. And so where would you see ENVRI infrastructure in this diagram? Because how much, the Fluxnet is integrated into research infrastructures?
So let's say in terms of definition of research infrastructure, I think ICOS is a research infrastructure, and the other, I don't know if they can be defined as a research infrastructure. It depends on the definition, because the definition of the research infrastructure is, for us, it's a European definition, I guess. So Ameriflux, I don't know if they can call themselves research infrastructure from.
Yes, but for example, if I go to like metadata or any catalog from every, let's say, landing page, would I be able to find a Fluxnet? The Fluxnet, right?
Yeah. So for Fluxnet, we defined the minimum set of metadata that they have to upload, and that will be provided together with the data. So the user will get the data file and the metadata file, where you have of course, the coordinates, the sensor's height, the sensor depth in the soil, and the canopy. You can have the leaf area index and the vegetation, the canopy height of the vegetation. So this is where we are. In IGOS, probably we have a lot of metadata, because we are doing this since 10 years. But yes, the ambition is also to extend this to Fluxnet as well.
Okay, that's Great. Thank you.
Thank you.
I think actually it's not too much of a question. Well, the thing is that I was at some point thinking that because you call it a shuttle, whether you actually wait for these stops, let's say. I mean, it sounds like maybe you need to wait for the first one to fill up, then the other one, then the other one. But I guess not, right? The frequency, you're just turning around. I mean, revisiting all of them.
This also depends.
I mean, they're not supposed to be in sequence.
No, of
Because
course.
it seems like there's a
Yeah,
sequence.
this is just
There's none, right?
No, this is not right.
Okay.
Right. It also depends on the way the user will look for, because there are several parameters. So one can look for a single station because maybe they know the name of the station. So the shuttle will visit only the basket that is relevant for this station and find or not these data sets, depending if it has been released or not. Or one can also look for by coordinates. So by giving an area, I need all the stations of this area. And so in this case, he has to but he does know how which basket to visit, depending on the query. Yes.
Simone, correct me if I'm wrong, but Ameriflag has two different networks, Base and the FluxNet, separately. So
Say again?
the Ameriflux
Yes.
has two different subnetworks, the Base network and the FluxNet. Most of them are actually not included in the FluxNet. Will they be also included in the this new merging? Because
so the base, as far as I know, no. The base is something a little bit different because it's not only the in situ data. So what is in the Ameriflux is all the stations all of the Dicovariant stations that are part of Ameriflux, and the ones that are provided by Neon and LBA for the South America, while the base is a little bit different.
Okay, so yeah, thank you one more time, Simone.